NASA and the European Space Agency's recent release of new images of the interstellar comet known as 3I Atlas has captured the imagination of scientists and space enthusiasts alike, offering a rare glimpse into an object that originated far beyond the boundaries of our solar system and is now making a fleeting visit before disappearing forever into interstellar space. Discovered in late June and officially confirmed as only the third known interstellar object ever detected in July, 3I Atlas has since become something of a cosmic celebrity, racing through the inner solar system at an astonishing speed of approximately 130,000 miles per hour, or 210,000 kilometers per hour. A velocity that reflects both its alien origin and the immense gravitational forces shaping its trajectory. Over the past several months, this massive, icy body has drawn intense scientific attention as it passed close to Mars and made its nearest approach to the Sun in October, an event that dramatically increased its brightness and activity by heating its frozen surface and triggering the release of gas and dust into space. Now, as it heads toward its closest encounter with Earth on December 19th, when it will still remain a safe distance of about 170 million miles, nearly twice the distance between Earth and the Sun, astronomers are seizing every opportunity to study it in detail, using some of the most powerful instruments ever built. This closest approach, while far from posing any danger, represents a crucial observational window during which researchers can analyze the comet's structure, composition, and behavior under solar radiation, providing insights into conditions that may have existed in distant star systems long before our own solar system formed. As part of this effort, NASA's Hubble Space Telescope and ESA's Jupiter Icy Moons Explorer, known as JWST, have been playing key roles in capturing high-resolution images that reveal the comet's evolving appearance and remarkable activity. On December 4th, NASA released a striking Hubble image taken on November 30th, showing a glowing white point at the center that represents the comet's nucleus and surrounding coma, a cloud of gas and dust that forms when ice on the comet's surface sublimates under the sun's heat. Around this bright central region, background stars appear stretched into elongated streaks, a visual effect caused by Hubble's camera tracking the fast-moving comet rather than the distant stars, emphasizing just how quickly 3I Atlas is traveling through space. This image not only highlights the comet's brightness, but also provides subtle evidence of its dynamic processes, including faint jets of gas and dust erupting from its sun-facing side and the beginnings of a tail pushed away by solar radiation. Such features are typical of comets as they approach the Sun, yet in the case of an interstellar visitor, like 3I Atlas, they offer especially valuable clues about the materials and physical conditions present in other planetary systems. The November 30th observation was taken when Hubble was about 178 million miles from the comet, significantly closer than during its first encounter in late July, when the object appeared only as a blurry blue smudge. Despite the limited detail in that initial image, scientists were able to estimate the comet size, concluding that it likely measures somewhere between 1,400 feet and 3.5 miles in width, making it potentially the largest interstellar object ever observed passing through our neighborhood. This size estimate alone has important implications, suggesting that large, comet-like bodies may be more common in other star systems than previously thought, and that some of them occasionally wander into interstellar space where they can eventually intersect with systems like our own. While detailed data about the composition of the comet's coma from the latest Hubble images has not yet been fully released, researchers expect that upcoming analyses will shed light on the chemical makeup of its gases and dust, potentially revealing whether it resembles comets formed in our solar system or represents a fundamentally different class of object shaped by alien environments. Complementing Hubble's observations, ESA's JWST spacecraft has provided another compelling perspective on 3I Atlas. Originally designed to study Jupiter's icy moons in the search for signs of life, JWST happened to be in an ideal position to observe the comet as it passed relatively close by shortly after its solar encounter. On November 2nd, when the spacecraft was only about 41 million miles from the comet, it captured images showing a particularly active and energetic object, surrounded by a bright, glowing halo of gas and displaying hints of two distinct tails. According to ESA scientists, one of these tails appears to be a plasma tail, made of electrically charged particles that interact strongly with the solar wind and extend in a direction influenced by the sun's magnetic field, while the other seems to be a dust tail, composed of tiny solid grains pushed outward by sunlight and following a slightly different trajectory. The presence of both tails underscores the complex interplay between the comet and its environment, as solar radiation, magnetic fields, and particle streams combine to sculpt its appearance in real time. Observations like these are particularly valuable because they allow scientists to compare how an interstellar comet behaves under solar conditions with how native comets from the Kuiper Belt or Oort cloud respond, potentially revealing subtle differences in composition, structure, or thermal properties. More broadly, the study of 3I Atlas represents a rare opportunity to conduct direct forensic analysis of material formed around another star, carried across vast distances of space and time before briefly intersecting with our own cosmic neighborhood. Each measurement of its brightness, spectrum, motion, and outgassing pattern contributes to a growing database that helps astronomers refine models of planet formation, stellar evolution, and the processes that eject debris from young planetary systems into interstellar space. The fact that this is only the third confirmed interstellar object detected so far, following Oumuamua in 2017 and 2I Borisov in 2019, highlights both the rarity of such discoveries and the rapid progress of modern astronomical surveys, which are becoming increasingly capable of spotting faint, fast-moving visitors against the crowded background of stars. As observational techniques and instruments continue to improve, scientists expect that more such objects will be found in the coming decades, turning what are currently extraordinary events into more routine opportunities for study. For now, however, 3I Atlas stands as a unique and fleeting ambassador from another star system, offering a brief but profound glimpse into the diversity and dynamism of our galaxy. Its dramatic journey through the inner solar system, marked by close passes to planets, intense heating by the sun, and close-up scrutiny by humanity's most advanced space observatories, serves as a reminder of how interconnected and ever-changing the cosmos truly is. As it recedes from Earth after December 19th and gradually fades from view, heading back into the depths of interstellar space, it will carry with it the accumulated data and discoveries gathered during its visit, leaving scientists with new questions, refined theories, and a deeper appreciation for the vast, unseen traffic of objects moving silently between the stars.